Hello, lovely people. How are you doing today? Today we are going to look at complex numbers and how to resolve problems involving complex numbers. Now we are given that y equals to 4i minus 2 and x equals to 1 minus I. And we are asked to determine the real of x, y. X times y. That's what it is. Determine the real. Remember, for every complex number, the expression is giving us a plus bi. Where you have the number is called the real part, and this is called the imaginary part. So in this case, they are asking us to get the real of this expression when we multiply them. Two things we must note before we start the basics. When I is raised to power 2, when I is raised to power 4, or factors of 4, remember I raised to power factors of 4 is going to give us 1 always. And we also remember that I in itself is root of negative 1. Then it means that when you square the root of negative 1, then you have I squared as negative 1. So with this basic, we can go on and simplify this expression. Real of xy. So let's go through this. Xy means multiply x and y and write out the real part of it. Leave out the imaginary part. So our x is 1 minus I, and we have our y as 4i minus 2. Now, let's use distributive method to simplify this. 1 times 4i is 4i. 1 times minus 2 is minus 2. Negative I times 4i will give us negative 4i squared. And now negative I times negative 2 will give us positive 2i. Simplifying going forward, we have, let's call it like terms, or let's go one step more. 4i minus 2 minus 4i squared is replaced with negative 1 plus 2i. No need to put root of negative 1 here, we'll be making it to be complex. We want it in the form of a plus bi. Now let's call it like terms. We have 4i and we have plus 2. That gives us 6i. And then from numbers, negative 4, negative 1 is plus 4. Negative 2 plus 4 is 2. So we have 2 plus 6i as the final answer here. So it's negative 2 plus 4, which is 2. 4i plus 2i, which is 6. And they want the real part of it. So the real of x times y is 2. If they wanted the imaginary would have been 6. Please, not I. I is also imaginary. If they wanted the imaginary part, it would have been 6. So this is the real of this. Now let's go to the second question. The second question, they are asking us for the conjugate of that. Please, whenever we have this star on complex number notation, they are asking us the conjugate. What is a conjugate? Whenever you have the imaginary, the conjugate means that the sign of the imaginary must change. So this is the original. Now, if I want to take the conjugate of this, the conjugate of x, the imaginary is negative here, it becomes positive I. Multiplying the conjugate of y. Please, the conjugate is not negative 2 that will change, but the conjugate is applied on the imaginary part. Just like when we have surd, the conjugate is applied on the surd, not on the number. So we will have negative 4i minus 2. Please note, it's very important. It's not on the middle, but the conjugate is applied on the imaginary. Now, that is all. We just do our distributive and get the final answer. So here we have negative 4i minus 2, then minus 4i squared. I times 2 is negative 2i. Now, let's go to the next step. 4i minus 2 minus 4i squared is negative 1 minus 2i. Now, let's call the like terms. This is negative 4, negative 2i. That's negative 6i. And then this is negative 2, negative 4, negative 1 is plus 4. So this is negative 2 plus 4. And that gives us positive 2. So our answer is 2 minus 6i. Our answer is 2 minus 6i. Remember, the conjugate is very important. Getting this alone gives you almost all the marks before you even start simplifying. Now let's look at the third question. The third question is asking us to determine the value when x is divided by y. Now we have 1 minus r being divided by y, which is 4i minus 2. Now we treat this like we treat surd. If we have a surd in the denominator, we cannot leave it like that. We have to rationalize. We have to rationalize. And how do we rationalize here? To rationalize, we multiply both the numerator and the denominator with the conjugate of the denominator. Remember, the conjugate of the denominator multiplies both the numerator and the denominator. So the conjugate here is negative 4i minus 2. We multiply the denominator with the same conjugate of the denominator. Please, the conjugate of the denominator. Now, we can simplify using ordinary algebra. Now let's go numerator to numerator, denominator to denominator. Now we have 1 times this is minus 4i minus 2. That's our numerator. This gives me plus 4i squared. And then this gives me plus 2i. We are done with the numerator. Let's go to the denominator. Please check for signs. I'm always terrible when it comes to signs sometimes. Alright, now let's go to the denominator. 4i squared times minus 4i squared will give me minus 16i squared. Minus 16, 4 minus 16i squared. Then 4i squared times 2, negative 2 is minus 8. So let's write everything, no need to take shortcuts. So I have minus 8i. Negative 2 times negative 4 is plus 8i. Negative 2 times negative 2 is plus 4. Now, if we look at this, you see that we have like terms here. When we are simplifying, minus 8, we cancel out plus 8. This is like taking difference of 2 squares for the denominator. Now let's simplify the numerator. Remember, we want the answer in form of a plus bi. So let's call it like terms. Now this is negative 1i squared. So this will be negative 4i plus 2i will give me negative 2i. Negative 2, this is 4 times negative 1 is negative 4. So we have negative 2, negative 4, that's negative 6. Divided by 16. If we have negative 16, I squared is negative 1. Negative 16 times negative 1 will give us positive 16. So we have 16 plus 4 is equals to 20. 16 plus 4 is equals to 20. They want it is in this form. We have rationalized because there is no element of complex number or r on the denominator. Please, that is how you know that you have rationalized properly. there shouldn't be any I in the denominator. That's the purpose of rationalizing in the first place. Now, we can now allocate this denominator to individual values in the numerator. So I will have negative 2i over 20 minus 6 over 20. So this is the complex notation of this. You can reduce it to the smallest possible fraction, which is negative I over 10 minus 3 over 10. That is the simplest. So our final answer will be negative I over 10 and then minus 3 over 10. And that is x over y in the form of a plus bi. So it's negative 3 over 10. Our a is negative 3 over 10 and our bi is negative. So it is negative 3 over 10 minus I over 10. So this is how we will simplify. Please pay attention to the basics. The foundations are very important, and you cannot present anything without getting the conjugate. You use the conjugate to rationalize whenever fractions are involved with complex numbers. And that is how we break it down. So please share this video, subscribe, encourage your friends to subscribe. I'll see you in the next video.